Hi everyone. Today what we're going to do is actually create our own Punnett squares. In your previous activity, you did have the chance to see what Punnett squares look like, but the computer filled everything out. Today you're going to be responsible for filling everything out. I'd like to just review these steps really quickly and you can see what they look like in practice. We always want to identify the trait being studied, make sure we know what is dominant, what is recessive, identify the genotype of the parents, be able to put the genotypes on the Punnett squares, segregate, distribute, and then from the Punnett square, we can identify the genotype and phenotype of all of the possible combinations of offspring. I have a real life example that I wanted to share with you. These are two cows here. You can notice one has a set of horns and one does not. Horns in cattle follow a simple dominant recessive relationship. The allele types are horns or no horns. Dominant are cows that have horns. Recessive are cows that do not have horns. What I've done here is I've represented a capital H as being the dominant allele and a lowercase h as being the recessive allele. There are three possible allele combinations that you could get. You could get big H, big H, little h, or little h, little h. Those are the three different genotypes. There are only two phenotypes, and they include horns, and that occurs when you have big H, and big H, little h, or no horns, which is little h, little h. Let's see what this looks like in a Punnett square. So our original example of the cows right in here, we can cross a heterozygous horned bull with a polled cow. So just to give you a little bit of vocabulary background, bull is a male cow and a cow is a female cow. Horned obviously is horns, polled means no horns. So what this looks like is we have the bull up on the top, we have the cow on the side. Heterozygous means that you have a big H, little h. Oh, look, I didn't do H, I did B. Oh well, we're going to go with B's here. I have big B, little b, and then for the cow, we have little b, little b. The first step that you want to do is segregate your alleles. We know that Mendel's law of segregation says that each allele has an equal probability of being contributed to the offspring. So that's what it looks like on our Punnett square right in here. The next step that we want to do is distribute the alleles. You'll notice first that I tend to do the columns. So my big B is going to go down the column. Then my little b will go down the other column. Then I do the rows. So I'll have my little b's going across the first row and my little b's going across the second row. This gives us four different combinations that we can have of all of the alleles. The genotypes, you'll notice that there are two big B, little b, and two little b, little b. What are the resulting cows going to look like, or the offspring? Well, their phenotypes, we will have two with horns and two without horns. So that's what it looks like when you actually do your own Punnett square. You're going to have a chance to do that after I show you another example. How do I make this all stop?
In this example, we have two critters. One is named Ocean, one is named Lucy. They're second generation critters, and each one is heterozygous for the blue-tailed trait. What we need to do is draw a Punnett square that shows the possible allele combinations of their offspring and what is the probability of them having an orange-tailed critter. Well, first thing that we want to do is identify the trait being studied. It appears as though the trait that we're going to be studying in here is tail color. The next thing that we need to do is identify the dominant and the recessive alleles. And it tells me that I should use the letter of the dominant allele. This one can be a little bit confusing because we need to go back and see what information is in the description. So we know that we're studying tail color, and we know that we have outlined in here a blue tail and we have an orange tail. So we know that those are the two different forms of the allele, blue and orange. Now we need to figure out which one's dominant, which one's recessive. When I go back, it says that each one is heterozygous. Well, we know that heterozygous means that they're going to have both a capital and a lowercase allele. We also know whenever you have a heterozygous allele combination, the dominant trait is going to show. So because this says that it is heterozygous for the blue-tailed trait, that means that the trait that is dominant is going to be a blue tail. So I'm going to use a capital B to represent that. So the dominant allele is going to be blue. The recessive allele is going to be orange. So I can go ahead and I'm going to write it that way. So a little b is orange, which is recessive. Dominant is a capital B, or a big B, which is blue. So if I wanted to, I could just write myself a little note in here, blue and orange. That'll just help me remember it later on. Identifying the genotypes of the parents. Going back to the problem, it tells me that each one of them is heterozygous, which means that they have a big B and a little b. Now I can fill out my Punnett square. So when I look at my Punnett square, what I need to remember is that I have to put one parent on one side, the other parent on the other side. In this example, what I'm going to do is I'm going to put the male on the top, ocean, big B, little b, and then the female, whose name escapes me. What is the female's name? Lucy. I'm going to put Lucy on the side over here, big B, little b. Next step is to segregate the alleles. That means that I just put one allele in each row and one allele in each column. So I'm going to go ahead, I'm going to put a big B here and a little b there. Those are Ocean's alleles. And then I'm going to put Lucy's alleles over here, big B, little b. Next step is to distribute the alleles. So first thing I like to do is go down the column. I have big B, and then I go down the other column. I have little b, and then I'm going to go across the rows. Big B, and then over here I have little b's that I need to distribute. I've filled out my Punnett square, and now it's time for me to interpret the information that's in there. If I wanted to interpret the genotype and phenotype of the offspring, easy thing to do right in here is for my genotype, I have one that is big B. I have two that are big B, and then I have one that is little b. And going back to describe what the phenotype is, well, I know that the capital B is for the blue tail, and it is dominant. So anytime you have the genotype with the dominant, it means that the phenotype is going to show the dominant trait. So that means I will have 3 blue-tailed, and I will have one orange-tailed offspring. The last question that I have on here is, what is the probability of them having an orange-tailed offspring? Well, if I count out the total number, there are 4 possible offspring. 1 out of 4 has a chance of being the 2 recessive alleles put together, which will allow for the recessive trait to show.